Hi, welcome back to the online statics review sessions. In this session, you'll learn about friction forces, and remember that we are in statics, which means we're analyzing bodies at rest. So we will analyze friction before it start moving. What we mean with that, if you look at this box, resting on the ground between two surfaces then try to apply a force and increase this force, there will be resistance between these two surfaces. This resistance is presented by that friction force, the force we call it friction, and associated with that is a normal force perpendicular to the surface. These two forces actually are a resultant or component of a force that is with an angle applied to resist that motion. But we will always analyze a friction force parallel to the surface and normal force perpendicular to the surface. Because we are in statics, which means we're analyzing bodies at rest. So we try always to analyze either whether this force will start move this object, or what is the force that will put this in motion. This situation of motion or about to move, we call it impending motion, and which means that when the force would or the friction force would reach its maximum, and this maximum force depends on the factors, which is the types of surfaces in contact, material and surfaces in contact, represented by the coefficient of static friction mu(s), and the normal force, which is actually subject to the weight of that object. So we always analyze two important cases, or there's two important situations. One is when the force is given and is asking whether this will put this in motion or not. In that situation, we have to find the friction force caused by this force, and then compare it with the maximum. If it's greater than the maximum, then the system will move. If it's less, then it will not move. The other situation is when the force is not given and it's asking what is the force that will put this in motion, or in other words, what is the force that will put this friction to reach its maximum. And in that case, then we set right away the friction equal to maximum and then calculate and find the force. We have also to check for another case, like if this will slide or it will tip. Tipping occurs if this distance x is greater than half the width, then it will tip. If it's less, then it will slide. So another case or situation of friction is that occurs between surfaces of a belt and like in that case there's a drum or anything that rotates to transform rotation between an object to the other. Very common examples are motors or engines or saw, where you have a rotating circle and connect it with a belt that try to move this belt to create the rotation in another object. A fan also is in another situation. So if you these in this situation, we have first to look at the direction of impending motion, or the motion that would happen if the T1 would be greater than T2. With experiments, it was found that T1 can be greater by than T2 by E equal to the power of mu times beta, where mu is the static coefficient between these two surfaces in contact, and beta is the angle in contact between the two surfaces. So it starts contacting here and end at this point, and this beta is always measured in radians. We'll see this in the example how we calculate that. So let's do an example. In this example, you have P, a force. What is the magnitude of that P that will put this system in motion? So we need to find P that will put it in motion, or that would try to move it. So the first step, this is first, you have two boxes on top of each other. This box, the surface between the two boxes has a coefficient of static friction of 0.35, and there's also another coefficient of static friction between the lower box and the surface, the ground, or whatever is below that. There's also a coefficient between static friction between that belt or the cable and the drum that is sitting there as not rotating. So you have a friction also between these two surfaces. So when you look at a case like an example like this, you have first, before starting any calculations, to think what is the possible motion that could happen. The first motion is that this box, when you apply the force, it will move in this direction. So it will slide over the lower box, which will create the friction force and the normal associated with that. So this is a case if you start increasing the force, so which means that this box will slide on top of the other one. The other case that we need to analyze is that this both boxes will slide as one unit uh, in that direction, which means that this friction is big enough to keep these two boxes together, and this will slide because this can be smaller, and it starts sliding this case. In that case, we have to analyze that this is as one unit, and we don't need to worry about this friction force, about this coefficient. Followed by that, once we find both, then we take the smallest one, and then because this is the case that will happen, and then further continue calculation to find what is the value of that P and answer the question. So we start analyzing and then start with that case. If this box will slide on top of each other, of the lower box. So we apply, first draw the free body diagram showing that force P, friction force always in the opposite direction of the motion. So the motion is to the right, then the friction is to the left. This is how it will resist it, and the normal force is perpendicular to the surface. Applying the equation of equilibrium, we can start by forces in the vertical, and then we have only the n and the 30, and then calculate the n, and then after that calculate or find P with a knowledge of F. Here notice an important step that we did. We set already that the friction force to reach its maximum, because the question asks what is that P that will put this in motion, or what is that P that will make the friction force to reach its maximum. That's why we already set the friction to equal us times n. So followed by that, to find that P with the knowledge of the normal force that we found from the forces in the vertical, forces in the horizontal, gets you that P1 is equal 10.5. So this is the first case. Now we analyze the second case, applying the equation of equilibrium. You have the force, you have both boxes, and you have the friction in the opposite direction. So again, the motion is to the right, and friction has to be to the left, resisting this motion with the associated normal perpendicular to the surface. So we start applying the forces in the vertical. We have the weight of both boxes, 30 and 40, and the normal force, which get us that N is 70 kilonewton. And again, we already said that friction force is to the maximum, because we need to find that P that will put this in motion, or that what is P that will make this friction to reach its maximum. So applying the horizontal forces equation, and you can find the P2. So P2 here is 14 kilonewton, which means that when you start increasing the force, and then once it reaches the 10.5, then the system or that box will start sliding, which means that this case will never happen because the force will never reach the 14 kilonewton. So we take this 10.5 kilonewton and then start continue to calculation to find P. Uh, Using this formula, we first have to think what is the direction of the motion in that case. Now, obviously, because we need to find P, that will, when we pull in that direction, that will make this box to slide, which means that this is the direction of the impending motion. So remember that we said that in setting this equation, we have also to think that this T1, it's in the direction of the motion, has to be greater than T2 by e to the power of mu within beta. So if we just put this in this formula, then we have to be P has to be greater than P1 by this e to the power of mu times beta. Mu is given to 0.25, and beta is the angle in contact. So this is exactly 90 degree, and 90 degrees is in radians is a half pi of pi over 2, and then you calculate, you get this the answer. This is the final answer, that its force is equal 15.9. One last step that we didn't analyze is whether this slide. Now we know that when you increase the force, this force, to 15.6 kilonewton, then the box will start sliding because P1 will reach 10.5 and the box will start motion. So we have to analyze whether this box will slide or it will tip, because this is another important step that we have to do, which means that you have to find this value x. Finding a distance is with the moment equation. So if you take a moment about this point, point A, and write the equation, then you have the normal force multiplied by the moment arm rotating counterclockwise positive, and then subtract from that, because P, you have P rotating clockwise multiplied by the moment arm, extend from the point of rotation to the line of action, and this is a perpendicular distance is 1.5, and solve for x, applying that P1 is the 10.5, 30 we calculated before, then we can find that x is about, it's 52 centimeter or 0.52 meter, and which is less than half the width of the box, which means that this box will slide and it will not tip when P reaches the 15.6. This a final note for friction problems, you have to be very careful and when to set that friction force to maximum in a calculation and when not. So again, when the question asks what is the force that will put this in motion, then you can right away set that F is equal mu s times n, or what is the force that will make this reach its maximum. So you set it equal to maximum and you start finding P. Another type of question, when it P is given, when the force is given, and it asks you whether this force will put this in motion or not. So it's asking you whether this force will make the friction force reach its maximum or not. So in that case, you don't set this equal to maximum. You just find F with the knowledge of P and N and the weight, and then compare this friction force to the maximum force, and then in this question also the us will be given, and then if it's greater, then it will move. If it's less, then it won't. If if it won't move, also another check that you have to see, maybe it won't move, it won't slide, but it will tip. So then you have also to find this x value. This wraps up the friction force, and thank you very much.